While modern construction relies on expensive materials, specialized tools, and professional contractors charging hundreds per hour, the Amish build sturdy, long-lasting structures for a fraction of typical costs through techniques that seem odd until you calculate the savings. These 10 methods cut construction expenses by 40–70% without sacrificing quality. Timber framing. Modern stick-built construction uses dimensional lumber nailed together in patterns that require enormous quantities of wood. The Amish build using timber framing, massive hand-hewn beams joined through mortise and tenon connections that use almost no metal fasteners and create structures lasting 200 years or more. The lumber comes from trees on their own property, cut and milled using portable sawmills or community mills. A 40-foot barn requires approximately 20 large beams rather than hundreds of 2x4s and 2x6s. The material cost runs $2,000 to $3,000 compared to $15,000 or more for conventional framing lumber. The joinery technique creates incredibly strong connections without nails. Each beam features precisely cut mortises, rectangular holes, that receive tenons, matching rectangular projections from adjoining beams. Wooden pegs lock the joints permanently. This ancient method produces stronger connections than modern nailed construction while eliminating dependency on metal fasteners whose prices fluctuate wildly. Community barn raisings provide free labor. 50 to 100 men can frame an entire barn in a single day through coordinated effort. The modern equivalent would cost $50,000 to $80,000. The Amish complete it for $8,000 to $12,000 in materials. Stone foundation. Fieldstone foundations using rocks gathered from properties and surrounding areas cost almost nothing compared to poured concrete foundations that run $8,000 to $15,000 for typical structures. The Amish collect fieldstone during land clearing and farming operations, stockpiling it for future construction needs. The stone costs nothing beyond labor to gather and transport it. Dry stacking techniques or minimal mortar create foundations that last indefinitely with virtually no maintenance required. The construction involves laying stone carefully to create stable, load-bearing walls. Larger stones form the exterior faces, while smaller stones fill interior spaces. The minimal mortar approach allows water drainage that prevents the moisture problems plaguing many modern concrete foundations. A stone foundation for a 30 by 40-foot barn requires approximately 2 to 3 weeks of labor but costs only $500 to $1,500 in materials, primarily mortar if used at all. The same foundation in poured concrete costs $8,000 to $15,000 plus substantial equipment rental fees. The durability proves remarkable. Stone foundations built 150 years ago still support structures perfectly. Modern concrete foundations begin cracking and failing within 50 years, requiring expensive repairs that stone simply doesn't need. Plank flooring. Hardwood flooring costs $8 to $15 per square foot installed in modern homes. The Amish create beautiful, durable floors for $1 to $2 per square foot by milling their own lumber from property trees. Portable sawmills costing around $3,000 allow on-site lumber production. A single large oak or maple tree yields enough lumber for several hundred square feet of flooring. The wood gets cut into rough planks, air-dried or keyline dried, then installed without the expensive finishing that commercial flooring receives. The planks go down unfinished, rough-sawn surfaces that get sanded smooth after installation. This approach saves enormous finishing costs while creating floors that develop beautiful patina as they age. The wear and character that develops over decades becomes feature rather than flaw. A 2,000 square foot floor costs $16,000 to $30,000 using commercial hardwood flooring. The same floor using home-milled planks costs $2,000 to $4,000 in materials, primarily nails, sandpaper, and finish. The $14,000 to $26,000 savings comes from eliminating middlemen, finishing costs, and commercial markup. The quality often exceeds commercial flooring. Old-growth timber from property trees features tighter grain and superior hardness compared to commercially available lumber from farmed trees. The sawmill investment pays for itself on the first house. Metal roofing. Metal roofing lasts 50 to 100 years compared to asphalt shingles that require replacement every 15 to 20 years. The Amish source salvaged or recycled metal sheets, install them with minimal specialized tools, and create roofs that owners never replace during their lifetimes. Modern metal roofing installed by professionals costs $15,000 to $25,000 for a typical barn or house. The Amish achieve similar results for $2,000 to $5,000 using salvaged materials and community installation labor. The metal sheets come from demolished buildings, agricultural structures, or metal suppliers selling surplus and discontinued materials. The sheets may not match perfectly in color, but this doesn't affect performance. The Amish prioritize function over aesthetic uniformity. Installation requires basic tools, metal snips, drill, and fasteners. No specialized equipment or techniques beyond what capable DIYers can learn through one project. The community work parties complete installations in days rather than the weeks professional crews require. The lifetime cost comparison proves dramatic. Asphalt shingles needing replacement 3 times over 60 years cost $45,000 to $75,000 total. One metal roof installed for $2,000 to $5,000 lasts the entire period with minimal maintenance. Natural insulation. Spray foam insulation costs $2 to $4 per square foot. Expensive solution that off-gases chemicals and creates disposal problems. The Amish insulate using straw bales, sheep's wool, or sawdust from their milling operations, achieving comparable R values for pennies per square foot or free using waste materials. Straw bales cost $5 to $8 each and cover approximately 10 square feet when placed between studs. A 2,000 square foot house requiring 200 bales costs $1,000 to $1,600 total compared to $4,000 to $8,000 for spray foam. Sawdust from milling operations costs nothing. It's waste product from lumber production. Packed densely into wall cavities, it provides R3, 5 per inch insulation value, similar to fiberglass bats. A house might use 20 to 30 cubic yards of sawdust that would otherwise require disposal. Sheep's wool from their own flocks becomes insulation after basic cleaning. The material naturally regulates moisture, prevents mold growth, and lasts indefinitely without settling or losing effectiveness. Commercial wool insulation costs $6 to $8 per square foot. Farm wool costs nothing beyond processing labor. The installation requires more time than modern methods but needs no special equipment beyond basic carpentry tools. The moisture management properties exceed synthetic insulation. These natural materials breathe, preventing the condensation problems that plague modern, tightly sealed homes. Window reclamation. New windows cost $300 to $800 each installed. Quality old windows salvaged from demolitions cost $20 to $50, with an additional $50 in labor for reglazing and minor frame repairs. The 15 windows in a typical house cost $4,500 to $12,000 new versus $300 to $750 salvaged. The Amish actively seek demolition projects where they can salvage windows, doors, and other materials before buildings get destroyed. The old-growth wood frames found in pre-1950 buildings feature superior quality and durability compared to modern vinyl or aluminum alternatives. The salvaged windows require some refurbishment. Broken glass gets replaced. Glazing compound gets renewed. Frames might need minor repairs. But the total investment, including materials and labor, rarely exceeds $100 per window. The construction approach adapts to materials rather than forcing materials into predetermined plans. When planning a building, the Amish first inventory available salvaged windows, then design the structure with rough openings matching what they already possess. This fundamental shift, designing around available materials rather than buying materials to match designs, creates enormous savings across entire projects. The wavy glass in old windows adds character that homeowners increasingly value. What modern construction considers defect, discerning builders recognize as desirable aesthetic quality, commanding premium prices when intentionally specified. Modern DIYers can replicate this approach completely, requiring only willingness to monitor demolition notices and invest time in salvage operations. Lime plaster. Drywall installation costs $2 to $3 per square foot, including materials, taping, mudding, sanding, and finishing. Lime plaster applied directly to wall framing or over wire lath costs $1 to $1.50 per square foot for DIY installation and creates superior walls lasting 100 years while repairing easily without the multi-step taping. Processed drywall requires lime plaster. Calcium hydroxide mixed with sand and water has been used for thousands of years. The material breathes, allowing moisture to pass through walls rather than trapping it behind vapor barriers, where mold grows invisibly. The breathability prevents the moisture problems endemic to modern drywall construction. Small cracks self-heal as lime continues curing through carbonation process that lasts decades. Larger damage gets repaired by simply applying more plaster to affected areas. No tape, mud, sanding, or repainting entire sections. A 2,000 square foot house requires approximately 40,000 square feet of wall surface, including both sides of interior walls. Drywall installation costs $80,000 to $120,000. DIY lime plaster costs $40,000 to $60,000 for materials and substantially less if owners perform their own labor. The initial application requires more skill than hanging drywall, but the learning curve spans just 1 or 2 rooms. The long-term maintenance advantages offset any initial difficulty. Lime plaster repairs take minutes compared to hours for proper drywall repair. Gravity water. Modern wells with electric pumps cost $5,000 to $10,000 for installation plus $30 to $50 monthly in electricity. The pump requires replacement every 15 to 20 years at $3,000 to $5,000. Over 30 years, the total cost reaches $15,000 to $28,000. The Amish alternative. Gravity-fed water systems using springs or creeks diverted to holding tanks positioned uphill from buildings. The elevation creates water pressure through simple physics. No pumps, electricity, or ongoing costs required. The initial system costs $1,000 to $2,000 for pipe, tanks, and installation labor. Properly designed gravity systems deliver adequate pressure for all household needs, including showers, laundry, and general use. The key requirement: water source positioned at least 40 to 60 feet higher than the building's highest plumbing fixture. Every 10 feet of elevation creates approximately 4.3 psi of pressure. 60 feet elevation provides 26 psi, adequate for most household purposes. Maintenance involves periodic tank cleaning and checking pipe connections, minimal work requiring no specialized skills or expensive parts. The system lasts indefinitely, with proper winterization in cold climates. Modern homeowners with appropriate topography can replicate this entirely, though municipal codes might require backup systems or special permits. Community labor. Hiring contractors for barn or house construction costs $30,000 to $60,000 in labor alone for structures the Amish complete through community barn raisings, costing only the price of providing meals for workers. 50 to 100 men gather at dawn on raising day. The timber frame gets assembled on the ground, then entire wall sections raised into position through coordinated effort. By sunset, the complete frame stands ready for roofing and siding that happens in subsequent work sessions. The reciprocal system ensures everyone benefits. Help given today generates obligation that brings helpers when your own building needs arise. The social enforcement proves powerful. Those who fail to contribute when able find fewer volunteers when they need assistance. The efficiency exceeds professional crews. Experienced builders direct younger members, teaching skills while accomplishing work. No time wasted on disputes, unclear instructions, or coordination failures that plague professional construction sites. Modern builders obviously can't replicate this advantage without similar community structures. However, the principle remains applicable. Friend and family help exchanges, skill shares, and cooperative building projects all reduce costs through reciprocal labor that money needn't mediate. The impossibility of replicating this advantage makes it oddly useful, primarily for understanding how Amish building costs stay dramatically lower than conventional alternatives.